Ladies and gentlemen, it's a great honor for me to start the Master Defense meeting. This is Nature 13040103, Power Plant Engineering. And first, let me introduce the members of the Compensation Commission. This is Presenting Management Executive, Doctor of Science, Department of Turbine Machines, Innovation Engines. Alexander Kalik, Head of Executive Power Engineering Department. Ekaterina Kudanina, Doctor of Science, Department of Turbine Civil Machines and Innovations Engines. Dina Moshkaramova, Doctor of Science, Department of Power Engineering Department, and Anko Kandida, Associate Department of Power Engineering Department. It's good to see all the respected professors, all graduate students, family and friends here. Let me remind the speakers that the time limit is 10 minutes, and then you will be questions. And the first presenter is Daria Belizhagina. The theme of her master thesis is Green Campus and Peter the Great St. Petersburg Polytechnic University. Advisor, Associate Professor Alyona Aroshina and Professor Esa Bakilan.
Hello, dear committee. It's a pleasure for me to present my master thesis today in this sunny day because sun is an important part of my work. And I am Daria Belizhagina and I am a student of biology program with the Branch University of Technology. In my master thesis, I would like to reflect on the experience and knowledge which I earned in the both universities. That's why I the master thesis called Green Campus in Future the Great St. Petersburg Polytechnic University, based on the experience of Ulm University. The aim of research was to consider the possibilities and conditions for creating the Green Campus in Polytechnic University. Also, I worked with documentation from LUT University and with the scientific and educational goals for development, energy renewable facilities in the Green Campus, and provides a critical view of using the fossil fuels trio in Russia in coal, oil, and gas. The object of research was the renewable energy facilities on the territory of Polytechnic University, its carport solar power plant, rooftop solar power plant, and wind turbine. So first of all, I would like to present the future of renewable energy and the importance of Green Campus in Polytechnic University, and after go through the Green Campus Design and Green Campus strategy. The inspiration for my work was the words of our rector, that new technologies and trends born in the university. So the concept of Green Campus is the eco buildings, the using of landscape areas, separate waste collections, the promotion of green life, and the creation in the comfortable condition for studying and education and future development of new technologies. What the effect on the energy sector in the world? Its megatrends and especially the growing pressure on ecosystem, increasing consequence of climate change, the intensive of global competition for resources, and increasing environmental pollution. All these factors they have to take attention and increase the number of carbon-less technologies in our life. The importance of Green Campus in Polytechnic University is to build the unique platform where students and staff can develop the new technologies and make a living laboratory where we can observe the behavior of renewable energy facilities such as solar, flags, and wind turbines, and create the infrastructure we can impact in the enterprises and manufacturing future. And the goal to optimize energy management system through the reduction of loads, increase the microgeneration such as solar plants and wind turbine, and development of energy storage, most known as smart grids. Um, as I already said, I based my master thesis on the experience of the Branch University of Technology, and it's just 200 kilometers between Lappeenranta and St. Petersburg, and other weather conditions are pretty same, and they are suitable for the development the renewable energy. In Lappeenranta University, there is very successful green campus development program by 2030, and it produced up to half energy in the campus. So in my development, I looked on the wind turbines, which implies that on the wind wind and the wind speed, and average wind speed in Lappeenranta and St. Petersburg, it's about 10 meters per second, and it's a good speed for the wind turbine production. For solar projects, I analyze the precipitation amount for Lappeenranta and St. Petersburg, and monthly and sunny days, because we need to maintain our solar projects and know how energy will produce. First of all, I developed the wind turbine. The area of our campus is really huge, and we can install the wind turbine as a symbol of green campus. It will be horizontal axis field blade turbine, and as I said, optimum speed 10 meters per second. The total height will be little, it's just 30 meters, and the blade length will be 6 meters. The proposal of this project will be install the wind turbine near Pavlov and optimize wind facilities for the development in St. Petersburg in the North region as wind power plants and so on. The main problem with solar projects is that we're living in urban area and we have to use a lot of areas. So the projects like carport solar plants and roof solar plants can use the areas of roofs and the parking places. Moreover, the sponsor law is observation that price for solar energy decreasing each year, and the technology development. That's why the solar energy each year cheaper and cheaper. The car power plant will be located near this building, scientific and research building, and the direction will be south and elevation is 15 degrees. And the benefits of that is that it's uncomplicated mounting system that will help us to earn energy from sun. We can use for the different solar panels, policy and buoyancy, and components of aluminium for installation will be make this construction version free and durable. So, and the last one is optimal charging point for electric vehicles. Here's the sketch of the profile of the project, and there will be gap for 2 cars and the possible production up to 100 kilowatt power. And yesterday I received the data from the Branch University. Then there in July was in June was a pretty big amount of energy production, and it goes to the university needs. The last one project was roof solar power plants. And here is the location of solar panels on the roof of scientific and research building and the installation project. During the future development, we will be choosing the models and type of well, panels, but in general it can be installed up to 114 panels. And we discussed the physical attributes of green campus, its objects of green energy and facilities, and overall technology. But green campus is not just the renewable energy project, it's a living laboratory where students and staff can develop the sustainable solution and work um, for enterprise and develop new technology, make Russia on the leading country in this field, and the culture, that sustainable culture of students in everyday life and research efficiency. To reach the Green Campus standards, we need to establish a Green Campus committee, undertaking the environmental review, implementing the action plan, and monitoring action that carried out, linking the program of our education work, and informing and involve the other students in our project. So, in conclusion, I would like to notice that was make decisions for the renewable energy facilities and action of introducing renewable energy facilities in university energy balance, and as suggestions with collaborations of other institutions will be make economic development for investments, promotional project, and during my PG, I would like to realize this project on the base of university. Thank you very much.
Thank you. Dalia showed excellent results throughout her education during master program. She's got 10 excellent grades, 4 good, and 0 satisfactory. Her supervisor will quote, the presented work deserves an excellent rating. Author Dalia Venjagina deserves a certification master in the field engineering and thermal. Do you have any questions?
Thank you for your presentation. Question about first part that the generation the power using wind. Let's present what about the effect also the generated energy. Do you estimate the value of energy that can be generated? So because I haven't seen it, maybe I just
Yes, we need to make a more detailed economic and payback research. But in general, this microtube wind turbine will generate about 10 kilowatt hour of energy. And yes, it's really a small amount. And yes, and the wind is not continuous. The effect, but yeah, the purpose of this work not to put the whole university on the renewable energy objects. Just take for students the optimal to make some research and involve they in the protection of our planet. Because I guess in Russia we need to be more in promotion of it and know more maybe educational courses. It's so important.
so it would be more a symbol of your house. One of the symbols. And as for solar part of generating energy, how it works when it. I'm rather far from this field, so I'm just interested in how it works in winter when we have a lot of snow, when we can have a lot of snow on the roof, for example. To be special stuff to
Yes,
to
yes.
clean.
It has to be the maintenance of these solar panels, and there was the project about the roof. There's the construction, and in my work there's standards how the construction can be. So we can obtain all solar panels on the roof to clean it and make production in the winter. Moreover, in the winter there is snow around us, and the sun irradiation goes more. Why
Yes,
is
due
it?
to
Why is
reflection, I see.
Yes,
Due to
yes.
reflection.
In sometimes in the winter time, the production can be more than in summer. But the problem of this region, North region, that we have a short day in the winter, and of course it's more powerful in the spring and summertime.
Do they have an operator also such on the roof or only on parking place?
Yes, they have a lot of facilities, and it's on the roof, on the walls, and it's the tracking system near the coast of Saima Lake. And everything, and the students make the laboratory experiments with it, and make videos every day to inform people how many energy was produced. So as I'm really proud of the technical university, and I would like to increase level in ranking, and I guess the green campus concept will help to reach our goals.
I have a question. That is about the electric power output of solar wind. And what can you say about the bad influence the snow and the rain to the surface of the plate?
Uh, the,
Is it a great influence or not? Not chemical influence.
no, the technologies are development, and the solar panels have protection from the, for example, acid rains and the other bad contents in the urban areas. Yeah, but of course we need to maintain the solar panels because it's really it's equipment which need be we need to be careful with it.
Yes, thank you very much. Thank you.
Are there any other questions?
My question is a bit short. Before you mount anything, you know which one. Yeah? So, do you have any major producers? Who are the major producers? Who would recommend? Do you have any major producers who you would recommend?
My development was I did this program Solar User Model, and there the huge list of the producers, inverters, and solar panels. But Solpen, I guess, one of the most profitable producers.
How much does a square meter of a panel, very good panel, cost? How much will it cost a square meter with good high quality?
It depends on the type of the panel. It's poly AC or mono AC, and the square meter can be variable. from the little ones, very huge, but for example, for carbon solar plant, we need to install light construction. That's why the area of panel will be about 2 square meter. The project will be cost about 70 million euros, and payback period will be about 26 years. Yes, it's huge, but we installed not just not to the purpose, not to just produce energy, but take for students possibility to make experiments. Thank you, Daria.
And our next speaker is Daniel Lopez, small-scale film generation from local solid beds. Supervisor, Assistant Professor Natalia Agaponova, and Vice Assistant
Good afternoon. My name is Daniel Lopez, and today I will be presenting to all of you my work titled Small Scale Steam Generation from Local Solid Waste. So, first, the aim of the research is to describe an efficient way to use the solid waste that is generated in every single community around the world. To prove the technical feasibility of a small-scale waste-fuel steam boiler, and to propose a practical method to produce steam in small regions, isolated or far away from the local grid. The aim of the research is to reduce the local solid waste, polluting small regions as well, quantify the energy that we can obtain from this kind of waste, and to determine an efficient way to produce steam from the combustion of solid waste. So I will talk a little bit about local waste handling, the combustion system, steam generation, boiler design, and just a tiny bit about the turbo generator set. So first, for the purpose of this work, we have to choose a set location to implement this idea. So it will be, in this case, Providencia Island, which is part of Colombia, but as you can see, this is Colombia mainland, and Providencia is right here in the middle of the Caribbean. It's closer to Nicaragua than to Colombia, so it's quite small and isolated from its main country. It produces around 11 metric tons per day, but it only has around 5,000 people. So the waste handling, how they do it? Right now, the waste handling is non-existent. They just take the garbage from one way and put it in another place. They don't treat it or anything. They just move it. So with this project, I'm proposing to take the municipal solid waste, which is all the produced waste from house activities and commercial activities, and treat them and turn them into refuse-derived fuel, which is the sorting of this waste, taking out the glass, the metal, the ceramic, everything that won't burn to produce a practical and more efficient way fuel. The combustion will be pretty simple because we're trying to make it small scale, so more technically efficient ways of combustion will be pricier and bigger. So in this case, we're just having a great fire boiler, simple. We put the fuel in, it burns, and we collect the ashes in the end. For the energy content, I followed a set of steps to know how much energy can I get. First, the typification. What kinds of waste is there in this kind of produced waste? The quantification. How much waste is there? Components analysis. How much of each particular element every component has? How much carbon, hydrogen, sulfur, nitrogen? The element analysis. Which element I will use to calculate the energy content? And from all these first steps, then I pass to how much energy in raw I can get from this waste in the form of the gross heating value, and then the net heating value, how much energy can I actually use. And from this, I finally get the thermal power. How much energy do I obtain from burning this waste in form of thermal energy? And all these steps I turn into a simple program in Excel in which I just put how much waste I get per day, the percentage, what kind of types I got, and this program will give me the total thermal power in kilojoules per second. In this case, according to our specification for this community, it will be 1,340 kilojoules per second. So now I know how much energy I got. So I'm going to use it to transform the energy into steam. For this, I need to know the main steam temperature, the main steam pressure, and the steam mass flow rate. And using a simplified schematic for a boiler, I can get, again, in an Excel file, the main steam temperature will be 400 degrees. Normal big power plants use 500, 550 degrees. But this is a small scale, so this will be the minimum viable temperature for machinery to work. The main steam pressure will be 2 megapascals, so still in the middle parameters. But the steam mass flow rate will be really low because we only have a limited amount of fuel per day. This system considers an evaporator, 2 superheaters, and the economizer. And this is the simplified boiler schematic design for the work, a simplified grade fire boiler, the evaporator, 2 superheaters, economizer, an air preheater unit. And normal big power plants have for the flue gases a lot of filters, a lot of steps to make it more low conscientious about the environment. But because we're just burning waste, which is not hazardous materials, in the island there is not a nuclear power plant to produce any kind of hazardous waste, so only a scrubber with water will cool down the flue gases and will permit safe levels for later exposure to the atmosphere. So for the turbo generator, now we have the steam, we know how much energy it is, so we have to turn it into something viable, something useful. For this, we use a turbo generator set to produce electrical energy. Thanks to the work I did in conjunction with my colleague Luis Barrera, who will talk later about his part, we know that this turbo set generator designed specifically for our power plant will produce 132 kilowatt hour of electricity, which only cover about 7.3% of the local power demand. So, for the conclusion, we completely give a solution for the local waste situation. We use all the waste produced every day. For the power demand, we only cover a small part, but we produce energy from something that will only be discarded otherwise. And we prove the technical feasibility of this idea. It's possible to do it, and there are the technologies and the means to produce it. We take the 11 metric tons per day with a boiler efficiency of 90, almost 90%, and we produce this amount of kilowatt hour electricity. So this was my work, and thank you for your attention. If you have any questions, I will be happy to reply.
Are there any questions?
What is the nameplate capacity boiler system to initiate full production?
We consider a capacity of around 1,400.
What is the nameplate capacity?
Yeah, but it will be.
What is the operation?
It will be less because of the fuel quality. I designed this boiler to be able to handle more in case we want to expand the production. But right now it will only handle a little bit less because we don't have much more to expand right now.
That was actually going to be my question. You envisage bringing waste from nearby regions for treatment?
Yeah, actually, The funny part is that in village other work it will be a little bit more strange, but this is Providencia. This is another island which is also part of Colombia.
Yeah.
These islands are part from another sector, I think this country, and this island is part of Nicaragua. So the boiler as design is for the minimal specification and can be modified for more production, which will comply with imports of waste. We can take actually the money, but it's only an idea that we can import waste from other places. We can solve their problems and create solutions for our problems.
Any other questions? Any other questions?
When you compare the value of this energy for burning the waste and energy producing energy.
Actually, this, I only specify about the technical part. My partner Luis will talk a little bit more in his presentation because we divide. It's a big work, which we did. So I will concentrate more on the burning of the waste, and he concentrates more on using it to turn into electricity. So the turbo generator set I talk about here, he will specify more of this work, and he actually compare the figures because right now they're using diesel generators, which consume quite a lot per year, and he would say how much in money it will save. It was considered, but in another part of the world.
Any questions? Thank you very much. Our next speaker, Jamal Baki Ali, waste heat recovery in the cement industry, supervisor, assistant professor Natalia Gafomova, supervisor, assistant professor Ms. Kalova.
Good afternoon. My name is Sar Oid. My topic is about the waste heat recovery of chemical cooler in the cement industry. My presentation outside production, methodology and result, and introduction. The cement subsector consumes approximately 12 to 15 of the total cement of the total energy use. Therefore, it's very important to buy technology to reduce the energy use because the energy consumption is a key that indicator the efficiency of the cement plant. One of this technology is the waste heat recovery. The waste heat recovery in the cement industry use the energy that lost from chemical cooler and by capture this heat and reduce the electricity or to reheat the raw material for enter the kiln. The essential function of the great cooler is to reduce the temperature of chemical cooler to the acceptable stage for more transportation and grinding. And there is opportunity to capture the heat from it. The goal of my thesis is to improve the efficiency of chemical cooler in the cement plant. I have two objectives. The first one, analysis the chemical cooler, the exergy and the energy of chemical cooler by consider the chemical cooler as a vacuum bed or assume chemical cooler as a system. The second objective is to make the waste heat recovery by three approaches: conventional and indirect waste heat recovery and direct waste heat recovery. This diagram shows the whole process in the cement industry, but in my study, I will focus in this part, this cooling, the great cooling, because this part will identify the efficiency of the system, of the cement plant. This diagram for great cooler consists of the three grades. The first one and third one is stationary, but in the middle is can move. Morphology. All the data I use in my calculation is actual operation. I take from the Muthanna cement plant is located in the south of Iraq. And this formula I use to analyze the clinical cooler when the clinical flow is considered as bucket bed. This also for the bucket bed. And this typical grade cooler. This grade cooler is will consider as a system, and this the energy input for cold air and hot clinical, and the output secondary air, tertiary air, and hot air on the cool clinical. This secondary air will go to the column again, and tertiary air go to the preheater, and the hot air I can capture this heat to produce the electricity by cogeneration cycle, and cold clinical will go to the crushing cooler, and after that will mix with the chips to produce the cement. And this formula for calculating the energy input and the energy output. And this is the same grade cooler, but this energy balance for the exergy, not for the energy. And this formula to calculation the energy and the exergy in the input and output. And this formula used to calculate the recovery, the energy efficiency and recovery energy efficiency. And this for exergy efficiency and exergy recovery efficiency. The second objective is the waste heat recovery. As I mentioned before, to calculation the waste heat recovery, we have three approaches: conventional and direct approaches and indirect approaches. This for conventional waste heat recovery. This simple Rankine cycle is consists of the waste heat recovery steam generation and steam turbine, and generation to produce the electricity, and condenser and heat pump, and this the heat losses from the clinical cooler, and the working fluid there is the water. This the second approaches is the direct approaches. We have additional process here where the working fluid go to the clinical and go to the waste heat recovery steam generation, because we have losses from radiation and convection here. And this indirect approaches, we have the recovery cycle here to recovery to the capture the waste heat from the lead cooler, and after that we have the heat exchanger to transfer the heat from the recovery cycle to the Rankine cycle. And this formula used to calculation the energy saving and emission reduction and cost saving and payback period. This formula. Result. This for the first approaches to analysis the energy and exergy. And this diagram is show the behavior of the temperature of clinical and cooling and cooling air and the exergy and the energy for both, and the heat exchanger. And this diagram is show the effect if I increase the mass flow rate of the clinical cooler, and what the effect on the another parameter. When increase the mass flow rate of the clinical cooler will be increase the temperature of the clinical and the temperature of the air and the exergy, and for both the cooler and for the clinical and the air. And this diagram is for when we calculate the exergy of when we calculate the exergy and the energy, when decreases the mass flow rate of the air will lead to increase the clinical temperature and the air temperature and the exergy and the energy. And this calculation, the result of calculation, will increase the residual time when come the clinical inside the cooler at long time. Will be increase the temperature of the air and the temperature of the clinical. And this, when calculation, as a result of calculation, when increase the grid speed of the cooler. When decrease this speed will increase the temperature of clinical and the temperature of the air. And this table for the energy and exergy calculation at the input and output of the from the system, all the heat from the system. And this data here in this column is taken from the Methana cement plant. This actual operation data. And this diagram to calculation the energy efficiency and the energy recovery efficiency and destruction of the exergy and the exergy efficiency and the exergy recovery efficiency. And in count losses. This will be this losses due to the convection and radiation inside the clinical cooler. And this for the second approach, the result of the second approach about the cogeneration. We have, as mentioned before, as I mentioned before, three approaches. This is the first one, the convection approaches, conventional approaches. And this result I get for the second and the first method and the second method, direct and indirect. And when I make the compare with all the methods I use it to recover the waste heat, I found the first one in the first method by the indirect approaches. And the exergy efficiency of cogeneration, the best method is what the conventional method. And this energy saving, the best approaches is the first method. And the emission reduction, the first method is better than the other approaches. And this table for cost saving and payback period for all approaches for the cogeneration. The payback period will be about 20 months to the payback the money, the investigation. Conclusion. Conclusion for the analysis. Decreasing the mass flow rate of the chemical cooler will lead to the increase the energy and the exergy of the energy and the exergy and the clinical temperature. And decreasing the mass flow rate will increase the temperature of the clinical and the exergy and the heat exchanger. And the gradient of temperature of clinical along the cooler decreases when the residual time is more when will be long residual time. And the temperature of clinical at the bottom of the bed is always less than the temperature at the top, because the cold air is enter the compartment from the bottom and go at the atmospheric temperature and go to the high temperature at the top of the bed. And the waste heat recovery or waste heat in the cement industry. This is about cogeneration. The energy efficiency and residual and energy cost and the emission reduction is based in the first method. but the exergy efficiency is built in the conventional method. But the payback period of all the method will be 20 months. Thank you for your attention.
Thank you. Academic showed excellent academic results throughout his education. It's 10 excellent grades for good and 0 satisfactory. And let me quote academic supervisor and inexhaustible interest, curiosity, diligence, responsibility, and desire to achieve results helped to write a serious scientific work that soon will be published in Scopus and it deserved an excellent grade. Are there any questions?
The payback period was 20 months?
Yes.
That is right. 60% per annum.
Yes.
Is that possible?
What?
How is that possible?
Small or much or?
It's gigantic, if I must say, because the standard, I think, returns on investment is somewhere between, lucky if you get 12%, now you are getting 60%, which is huge, massive. So I'm just asking how is that possible? Maybe a magic wand?
Yes, because I will get the net power is very high from the cogeneration. That's why I
Okay, so let's say how much is your input?
can't.
How much is your input? How do you cost your input?
The input is around 700,000.
700,000. How much do you cost your output?
The cost? No, this the cost of the investigation will be this one. And I will calculate the net or I get from the cogeneration. This slide. This. I will get the energy saving, but by multiply the net power plant for working hours. The working hours is around in the year 8,000 hours by day. And after that, I will calculate the cost saving is equal to the energy saving multiplied energy cost. Energy cost I take in this from this source. And after that, this payback period is what implementation cost is over the annual cost saving.
Yeah, so you count me in if you are going to make an investment because I'd like to take part in such an investment which is within 60% per annum. Okay, all right. Good.
Any other questions?
Say something about publications. Are you going to publish your book?
Yes.
When? In what?
I think in the university, because I sent my supervisor. I am going to develop this research about the use of the ANSYS because I want to study the distribution of the by ANSYS. I will use the another type of the fluid, working fluid, is nanofluid, by make little or particle inside the fluid to capture more heat from the great chemical cooler.
What part?
I answer that the study the distribution of the temperature because I want to model the great cooler and I study all the parameter when I increase the mass flow rate or increase mass flow rate of the temperature distribution because that's very important to estimate the waste heat recovery from this.
Any other questions? very much. I would kindly remind the presenters that apart from the audience that we have here, there are friends, family, and colleagues watching us online. So we would kindly ask you to present your thesis from this part of the room. You'll see video recordings here. Our next presenter is Tatiana Kalina. Her master's thesis is using the air cooling system and gas turbine plants to increase the power in summertime. Supervisor, Assistant Professor Alexander Kalit.
Good afternoon. My name is Tatiana Kalina. I'm going to present my master's thesis. It's using the air cooling system in industrial plants to increase the power in summertime.
It's summertime.
Oh, a moment. Wait, please. Yes.
My content consists from introduction of 3 chapters and conclusion. Climatic conditions such as temperature of the air are performance of the gas turbine unit, especially in the summer. The object of research is gas turbine unit of CHP22, which located in St. Petersburg. To calculate the amount of produced electric power, I made several steps. It's a dependency diagram of gas turbine unit electrical capacity from external temperature in the range of positive temperature. According to the graph, when the external air temperature increases, the electrical capacity decreases. The temperature changes were analyzed for over the last 3 years, 2014, 15, and 16 in the summertime. It's from the beginning of May to the end of September, 5 months. The maximum temperature in the year was 33 degrees Celsius. The nominal external air temperature for operation of gas turbine is 10 degrees. At an ambient temperature from +5 to -5 degrees Celsius, this anti-icing system is activated. And I take the average temperature between 15 and 5 degrees +5 degrees Celsius and take the +10 degrees of Celsius for further calculation. The amount of produced electric power was calculated for 3 years. It's 2014, 15, and 16. Here, EGT is produced electric power without air cooling system, and EGT with Exxon. This one is produced electric power with using air cooling system. And the amount of produced additional electric power is about 5% average. To cool the air at the inlet of gas turbine, it's possible to use 3 methods. It's evaporative humidification, compression, and absorption refrigerating machine. The maximum efficiency of evaporative humidification is achieved in hot, dry weather with relative humidity from 20 to 14%. In climatic conditions of St. Petersburg, it's not possible to use because the average relative humidity more than 16%. The use of compression refrigerating machine it's not considered because of low energy efficiency. And for calculate, I choose the absorption refrigerating machine for air cooling. Absorption refrigerating machine is industrial refrigerating system designed to extract, remove excess heat, and maintain the specified optimal temperature and heat conditions. It's a trade and expense of thermal energy. This principal scheme of operation was a lithium bromide absorption refrigerating machine. air, water, it's refrigerant, and lithium bromide, it's solvent. The weak solution is water lithium bromide solution. Weak solution is supplied to the absorption refrigerated machine that consists from 4 main parts. It's generator, condenser, evaporator, and absorber. The weak solution is supplied to the generator, where it is evaporated due to supply the heat source, like external, like hot water or exhaust gases. And the refrigerant vapor moves to condenser, where it's condensed due to the cooling water from here. And after that, the liquid refrigerant enters to the evaporator, where it's where the vacuum and it's liquid liquid boiled and cool their water. And concentrated solution enters through the absorber, where absorb the vapor from evaporator. And concentrated solution is pumped to the generator, where and after the recycle return again. The chilled water from absorption refrigerating machine enter to the heat exchanger, where it's cooled the air, which enter to the gas turbine mechanism. The possible source of thermal energy is steam, hot water, and waste heat gases. But in our case, we can't use waste heat gases because the minimum temperature for operation of absorption refrigerated machine, it should be 300 degrees, but we have only 100. And steam from low pressure drum of 50 cover steam generator and hot city water was chosen like possible source of thermal energy. I calculate the current capacity, it's equal 11 megawatts. And there are many companies who produce absorption refrigerated machine, and I choose, for example, one from St. Petersburg. It's named Energia Holodra. From I use the catalog of production and choose absorption refrigerated machine on hot water and two on separated steam. Calculate the payback period. It's really huge for absorption refrigerated machine works on hot water. It's 26 years, and machines on separated steam it's 22 years. In conclusion, despite significant increase in the capacity of the power unit up to 9% in the climatic condition of St. Petersburg, cooling to 10 degrees Celsius is economically attractive.
Thank you. Etienne Karenina showed excellent academic performance with 11 excellent grades, 3 good and 0 satisfactory. And according to the review of academic supervisor, she deserves an excellent grade. Do you have any questions?
What about publications? Not yet.
So what is the main result of your work?
My main result it's not economically unprofitable to use the absorption refrigerated machine in St. Petersburg in which power plant it's which HPM.
What would you recommend? Not use at all.
Not used in St. Petersburg in which kind of machines and decrease the temperature up to 10 degrees Celsius.
Any other questions? Thank you very much. Our next speaker is Ahmed Abdel Said, designer of energy supply chain for nuclear power plant in Egypt, supervisor of technical affairs at Iran.
Thank you for the whole team pointing up. Yeah.
Good afternoon. My name is Ahmed Abdel Said. I'm from Egypt, and I'm here to discuss my thesis about design of supply energy supply chain for nuclear power plant in Egypt. First, the aim of my research is to have a look on the situation of the current situation of energy in Egypt right now, and then including the construction of the nuclear power plant, and then design a supply chain for this nuclear power plant to give the stakeholder and the decision maker a view on how the design of the supply chain is to be affected and all the complexities of the supply chain. But at first, we need to have a look. First, this is first introduction, energy situation in Egypt, development of energy sector, nuclear power plants in Egypt, the location selection and connection points, then the assessment for the model for the connection points. Here, this is an overall look about Egypt, whose location is located in the north east of Africa and north east of Africa, with total area of 1 million square kilometer and population of about 92.7 million. The current situation of energy in Egypt is quite satisfying because we can generate electricity, the installed capacity is up to 35.2 gigawatt, and the peak is 28.1 gigawatt. And the energy mix is basically based on thermal power plants with 90%, and the other 10% is between renewables and hydro power plants. The average consumption of electricity per capita in Egypt is 1,627.8 kilowatt, and we have generation losses of 3.2%, and the transmission distribution losses vary between 10 to 14% according to the distance of the transmission to which point. The houses and residential is the highest consumer of electricity. After it comes the industrial sector, and the living comes sales of living countries, and would come to at the end of the customers. In the future, the expectations for the demand is to grow very high. Like since, as we see in 2027, it can grow up to 64.8 gigawatt, which is more than 100% increase in our consumption. And actually, this has two reasons. The first reason is the population growth in Egypt. We are expected at the same year to be about 111.2, and by 31 to be 118.6 million people. The second reason actually is a strategic development plan developed by the government in order to increase the industrial infrastructure and expand horizontally in Egypt because the population is basically concentrated around the Nile. These projects and this expansion will require a lot of energy to keep these places satisfied with energy and ensure the sustainability of this energy. Out of that, it comes the plan for development of energy sector. Besides the existing capacities, we will install new thermal power plants with 25.3 gigawatt and new renewables with 3.05 capacity gigawatt. But all of this will not be enough to satisfy the demand at the time because it will be 63.5 while our demand is going to rise to 64.8. Then came the idea of construction of nuclear power plant with 4.8 gigawatt. Actually, this will help us to satisfy the demand and we'll have more of energy. And at the same time, it will ensure a sustainable, uninterrupted source of energy for Egypt. And this will help a lot. And besides all of that, it will decrease a bit the dependence on the fossil fuels, especially now the fluctuation of the prices for the fossil fuels can keep the market unstable. So it's better to have a sustainable and not dependable on the fossil fuel. In November 2015, Egypt signed an agreement with Russia to install the nuclear power plant PVR 1200. It will be 4 reactor units, 1.2 gigawatt each, with total capacity of 4.8 gigawatt. It will be located in the Daba region in the north coast of Egypt, and it's planned to be, the first unit will be commissioned by 2024, and the whole power plant will be operational by the end of 2026. Here was the location selection for which place will be for the nuclear power plant. At first, we had several places, about 18 candidates, and following the fundamental of safety and protection for the International Atomic Energy Agency, we got that the Dawa site will be the one that's most favorable site for construction of the nuclear power plant. It was announced in 2010 after we got the approval from the International Atomic Energy Agency and the Nuclear Power Plant Authority in Egypt announced it. Here it was the Electricity Transmission Company announced that or recommended that these three connection points will connect the nuclear power plant with the electricity national grid in Egypt in order to connect all the power, because it doesn't matter. Yes, I generate, but I cannot connect it, so we need to connect it to this point to join the national grid. In order to connect it, we have several scenarios to connect this electricity using the 3 points. It will go to up to 7 models. The first model will connect to the first connection point. Second model, which is 1B, with second connection point, third connection point, and then we'll connect to 2 out of 3. The same other 2, it will go with each 2 connecting points. Then at the end, it will be 3 connection points. See here, Mahmoudiyya and Rasul. From here, in order to evaluate the connection points, we have to first take into consideration that the next generation for the power plant will be 40,000 gigawatt. The price for selling the electricity at the connection point will be $0.1 US for 1 kilowatt hour, which is $100,000 for the 1 gigawatt. The price for constructing 1 kilometer transmission lines from the nuclear power plant to any of the connection points will be $157,000. And the price of the excess energy from the demand, that if I have an excess energy in let's say I suggest at this point, and I have excess energy there that I get the zone is satisfied, but they still have more energy, it will be sold with this price, $0.89 US for each 1 kilowatt hour. Because the difference in prices, because we will have to pay for the transmission loss to compensate for further transmission losses. Especially that the average losses in transmission are equal to 3.1% for every 100 miles, which is 160.9 kilometers. After the evaluation, they came to this result that since this is the net generated from the power plant, and this will be the losses which will be calculated according to the distance between the connection point and the nuclear power plant, we will get that model 1A, because it's the shortest distance, will get the most energy from the power plant, while model 3 will have the least one because it will be sent to 3 different with more distance to cover by the transmission lines. In here, in this part, we are checking how much energy every model needs. Because I had this is the demand expected in 2027, and this will be the energy supply from the existing unit that we already have right now. So I will have, in order to meet the demand, I will have to generate this amount. We will be able to satisfy in model 1A, 1B, and 2A will be able to totally satisfy the demand, and we will have excess energy. This negative values means that in 1C, 2B, 2C, and 3, we won't be able to satisfy the total demand, and we will have to compensate this amount of energy from different resources from other power plants. Here it shows that after construction of the transmission lines and the cost of selling electricity, the net profit for model 1C will be the highest. So that's why model 1C is the most economic or favorable model, because we can make a very good economical benefit, and at the same time we will be able to partially satisfy the demand and that model. At the end, the development of energy sector is an important thing in Egypt right now because the expected demand is going to rise really high. So if we didn't take in consideration this right now, it will be a very big problem for us. We won't be able to satisfy the demand. The construction of the nuclear power plant will serve several targets and goals for the government and for us, because we will be able to satisfy the demand, we'll be able to decrease the dependence on the fossil fuel, and at the same time, we'll introduce new type of energy to our energy mix. The location selection for the nuclear power plant was very important for the safety and operation and safety for people, and it was selected based on the fundamental standards of the International Atomic Energy Agency. The selection of the optimum point here was based on the financial sector, on the financial point, and was based on the model assessment for each model
according to how much I will construct, how much I will spend to construct the line, and the demand for each point according to the model assessment explained. The results show that model 1C is the most economic option. Maybe it's not technically, we will not supply all the demand, but we will be able to make the most profit, and at the same time, the margin for the energy we need to compensate is very few. It's fewer than the rest of all the models actually. This analysis was made to put a highlight and show the decision maker in Egypt, since this is still in the future, to make the right decision, which is more beneficial, either they look from the social or the public service point of view or the economical point of view. Thank you very much. Thanks for your attention, and any questions?
First, let me grab again performance of his study and master program. It's 9 excellent grades and 5 good grades and 0 satisfactory. And according to the supervisor, this work deserves an excellent. Thank you very much.
Thank you very much.
Our next speaker is Luis Filipe Pereira, small-scale electric generation from municipal solid waste. Supervisor Professor Natalia Gavin, advisor assistant Ekaterina Skallo.
Hello everyone, my name is Filipe Barrera. I'm going to talk about the model steam turbine and electric generation from municipal solid waste, continuing with the work that Danny already presented to you. So the aim of my research will be solve the problem of municipal solid waste in 4 regions, enhance the problematic of electric generation in small regions, and propose a way to reduce the dependence of fossil fuels in power generation. My objectives of the research will be determine the energy potential of municipal solid waste, choose the best steam turbine and electric generator which maximize the results, and reduce CO2 emissions and also the cost of the electric generation. So this is the content that I'm going to discuss today. What is the current situation? As my colleague already told you, Providencia is really far from Colombia, and the actual demand is around 2 megawatts. The power installed is around 5 megawatts, which is pure diesel. The generation cost will be around 1 million, and the diesel gallons per year will be that is shown. As we know, municipal solid waste is a problematic in our societies and also in small regions. So they approach this problematic with 3 methods. It could be landfilling, recycle, and waste to energy facilities. Landfilling is becoming everyday problem because of environmental regulations, laws, and so on. The waste to energy, along with the recycle, are complementary methods. So because of landfilling is getting costly, this method is getting strength and is getting less costly. The location will be the same part of the landfilling, and it will bring all the benefits for creating power from municipal solid waste. So the projection of this work was taking account the number of people, the inhabitants in this region, and the total waste that they produce. We can and also taking account the capacity of the power capacity of the waste. We can calculate the savings that this project will get with an estimated generation of 158 kilowatts. The new demand will be reduced in 1.66, and the number of diesel gallons will be reduced also. The steam turbine that I was using for this purpose was an input back pressure single stage simple velocity turbine. The advantages is that it's easy to configure. It's more efficient and doesn't need cooling water. Disadvantages that is inflexible. We cannot vary the output and it cannot be regulated as well. Starting from the outputs of Daniel's work, from the steam generator with the pressure, temperature, and velocity that is shown there, we get the outputs using the nozzle angle in the nozzle area, assuming 93% of efficiency. Then with these parameters, we get the velocities, which will help us to calculate the length of the vanes, the blades, and the diameters of the diameter of the shaft. So what was what were the results? The results I summarize in this next graph. The power versus nozzle angle that suggests us three main points that we can use and two other points that we should take account in order to synchronize the selection of the steam turbine and the electric generator. And efficiency versus nozzle angle is a copy of the power versus nozzle angle. Another part that is important to see is the power versus mass flow rate with different angle of the nozzle. So in this one we see that it's more important get more mass flow rate than mechanical variations or on the design. And the other one is a non-scale graph that it shows how blade diameter affects those parameters: tangential force, efficiency, velocity, and power. We also can go for it in the market. So I choose, for example, this model that is inside the Siemens portfolio, and according to these parameters, it will fit with our project. The electric generation part, I also take into account how will affect the angle of the nozzle area in parameters like current and synchronous reactance in the generator. So as we see, it suggests two zones, these two zones to work, which maximize the value of the current, and it confirmed in the next figure that is the impact of the nozzle angle in the electrical power. So there we can see that if we want to get the more power, we should work in the first zone or in the second part. These are the parameters that I set up for the electric generator. it will depend, the speed will depend on how many volts we will choose to have in our generator. The number of coils will be 15, and the length of the coil will be 0.3 meters. And the power that it will develop will be 156 57 kilowatts. Those parameters there are the standards of the grid with 60 hertz frequency that is managed in Colombia and most of the countries in America. As well as the steam turbine, we can go for it in the market. And I choose this model from again from Siemens portfolio, which will fit perfectly with our design. So results of the project. Taking into account the usable waste and the generation waste that we can get from the waste, and with our calculations and with the set of our parameters in the turbine and the electric generator, we will get 133 kilowatts. The new demand will reduce a little bit in 1.68, which will represent just 7.29% of the demand of this agent, and it will represent in savings in $72,000 per year. Which, if you if you see this value, it's not so much, but compared with the amount of people who live in this area, it counts a little bit. And the CO2 emissions would be reduced in 639,000 pounds per year. So this is a table which I compared the projection with the values that was obtained in this project, and the deviation of these parameters are pretty much acceptable. Not so big. My conclusions would be the savings that I already said that is important for this amount of people. So the land filling in total, which will represent in less environmental pollution effects, like ground, soil and air pollution, and reduction of 320 tons per year of CO2 emissions. We will get cheaper and cleaner electricity. My suggestions. You were discussing a little bit before about this. That, for example, we teaching to people to recycle a little bit better. You can get better quality in the refuse, so you will get more power. If you want to raise the power that this project can develop, you can start to think about import municipal solid waste from where? From neighboring areas like Nicaragua and some other islands that are pretty close. So this is my presentation. Thank you for your attention. Questions?
We showed a good performance during his master degree program. It's 7 excellent grades and 7 good grades and 0 satisfactory. And his academic supervisor, one of these work results and excellent. Do you have any questions?
Continue. Answer the questions that previously asked. It's much clearer now.
Okay, thank you very much.
Your project.
Thank you very much.
And the speaker is Hashim Asrani. Optimization of technological process for reception, accumulation and loading of heavy oil from the tanks of the terminal tanks. Supervisor Professor Ibn Wanda, Advisor Assistant Professor.
Today I'm going to do a presentation of master thesis about utilization of technological proceeding, accumulating, loading up 40 and 100 fuel oil for the tank of the terminal tankers. This project is a beautiful combination between petroleum and mechanical engineering. I did this project with the Gorman University, and this is a project issues related to the optimization of processes for receiving high viscosity fuel oil, petroleum products M100 from the railway, the accumulating, the loading fuel oil from the terminal to the of the tanks to the tankers, taking into account the optimization of logistical constraints of freight traffic in the warm season from May to October. This is just like going to show you. This is, for example, tankers, and this will be seaport of Petroleum. This is in Amsterdam. The purpose of this object to optimize, I said, as I said before, section relating and loading of 40 or 100 fuel oil from the tanks of the terminal tankers. And I did some tasks to calculate the optimal capacity of railway overpass for fuel oil, capacity tank farm, and production capacity bandwidth, and for fuel oil of terminal in the cold and warm season, according to the project and after optimization, and also to secure the calculation of heat flows, fuel oil technology in order to verify work of oil heating station after fuel oil draining processes optimization, and to perform a calculation of pipes for loading of fuel oil in a tanker by volumetric pumps screw and in view kinematic viscosity of M100 fuel oil to provide a schedule of operation of the pumps. And finally, provide description of technology of discharging and loading fuel oil at the terminal with account automatic system of infrastructure, technological process control, and compliance to the requirements of the industrial safety, labor protection, and conservation environment. This is just I wanted to show you some the main idea of heavy crude oil. It is the maximum temperature should be 80%. If I'm going to heat it, that's why I wanted to do kinematic viscosity is lower. And some description about this fuel oil. I'm going to receive it from north part of Russian Federation by railway visit, and after I want to be in the cold weather, of course, and I'm going to preheat it. But if I want to do some difference between M40 and M100, it should be for M40 needs less time to preheat it. Because this characteristics is less time, and after from the railway to the these tanks on the terminal to the tankers ship, and this is I'm going to show you. Interesting. This is oil heating station of the terminal, and after this is for operation and also for heating. This is special heaters of the pipes and this is pumps, and of course these filters and valves with these valves with sensors. Maybe if it will be more than 80, that it will be close and it will be, it's okay. And after from this is the railway overpass, and after this to the tanks for storage, and after to the tankers. Sure. This is some beautiful calculations in the warm and the cold season for railway. Estimated tanks capacity 60 and number of tanks merged in a single feeding. It is 48, the same for both of them. And number of island tanks per day, 5 and 2.5. And coefficient of incomplete supply tanks, 1.05 and 1. The same also. And factor income differences. Tanks K2 is 1.20. And factor limiting work on the overpass weather condition K3 1.02, and coefficient of repair work K4 1.02, and finally the power will be 2 million, as according to these two formulas. For the cold season, it will be 2,011,600, 6,003 tons per year, and for cold season will be 1,305 tons per year. Actually, this information is from the terminal. There's a student, he worked from boarding in this terminal, and they helped me to get this information. This is some. This is I'm going to according to these two formulas. I'm going to estimated volume of the tank capacity and turnover ratio for the estimated volume of the tanks. I will show you here right now everything. The calculation of the fuel in the cold season, it means it will be the same. I'm not going to do heating because it will be more than 80 temperature, and it's, a great coefficient will be 1. And use tank capacity factor 0.88, and the density of the protects will be 0.92, and the annual it will be 1 million tons per year, and implement births will be 819. It will be changed, of course, after for the warm and after optimization. And this is the most important. The average daily volume of the transshipment tons will be 5,495. And number of normal days, of course, will be 7. This is cold season. And the final number ratio of the estimated volume will be 17. The calculation in the warm season will be different here. We can mention this is 2 million tons, and also this is before optimization. And the non-work day will be 3, of course. And finally will be turnover ratio. The estimated volume will be 31. But the beautiful, it's after optimization will be 2,336,000, and will be normal day, of course, will be 2 days, and turnover ratio will be 39. And the total, the increase of oil supply will increase the turnover of the tank crew, will be capacity 80,000 cubic meter. I mean, the ratio will be 31. This is before optimization, and after will be 39. And it means instead of 2 million, will be 2,336,000. And the volume transshipment of cold weather, of course, it will be the same because I didn't do these calculations. And this is also it is very important to do some calculations for how much I need pumps, how much supply, because maybe because of losses, because of there will be friction and angles. We can mention these. It will be after heating, maybe for example 70, 60. After this, it will be more than 80 because of losses, and I have to know how much pump it's need. I have 2 pumps working, and one is standby, and it will be final analyzed. It is 1,200 cubic meter per hour and pressure of 8 kilogram force second. And the final conclusion, it is And this project follow issues related to the optimization of technological processes were discussed. The reduction of logistical constraints traffic during the warm season from May to October, taking into account the condition of the weather and in the sea, of course, and calculate the pressure pipes for tanks and the increase of oil transshipment volume at the port by 11 percentage due to the intensification of protection process and effective use of capacities of the terminal and calculated the heat output of heating oil when it is being from the tank to the drain viaduct and find the calculated optimal capacity of the tank farm for the storage and transshipment of fuel oil. And I not forgot about economic effect of the optimization technology allows you to get additional profit at the expense of providing additional service for the growth of the volumes of transshipment by 11 percentage. Thank you for your attention.
Question showed excellent academic performance with 11 excellent grades, 3 good and 0 satisfactory. This work was carried out with consultations with experts from Iraq and according to academic supervisor Yunus Amonima, this work deserves an excellent grade. Do you have any questions?
Thank you. Tell me please, is the heating facilities situated on the ship? Yes?
No, it is in the terminal and in the terminal station only. And ship notes.
The second.
It's dangerous.
What kind of screw pump is applied for these purposes? The free screw, two screw, or one screw pump?
About this, I asked them. They only they sent me because I work with them there, and I asked about some information. It is it is for us. They said that it's general information.
Thank you.
Thank
you.
And I got some information. It's like
yes. Well, and the third question: what kind of fuel is applied for heating? Oil, maybe electric.
Yes. I use it is of course it's for heavy crude oil. There is two kinds of heavy crude oil. It's Alpha and Alpha 100. And I use there. I said before it is electrical thermal. It is for heating for pipeline. It is in thermal station. Only this, and I will get oil of course from station. As I said, here, oil heating station.
Yes, I can see. That's more.
Yeah, sorry, because it's no.
Thank you very much.
You're very welcome.
I understand.
Thank you.
Any other questions?
Back to the scheme where when you tell us about losses of income, I just would like to ask you, so how do you create this
This is
pipeline? So did you do some special?
yes, it is a symmetric program. It is symmetric name of this program. It is for do this. I work in this program with a student from Poland. And,
So you
and this student he was working with this also in the terminal. But for me, of course, it's not only me work with them, and he helped me to do these calculations, but also program math to do all this calculation.
Any other questions?
In this reality scheme,
Yes, reality.
one of
I will explain about this. Firstly, I wanted to do search about combination between petroleum, as I said, and methane. And this is necessarily this project, and this is all this real everything, and just about some information they gave me from the terminal, and it's a big project. They just helped me to get this information as my friend.
What is the maximum handling capacity? The maximum handling capacity.
The capacity is, you mean about
I mean, what is the total?
total.
The maximum capacity you can handle on the port.
As I said, it will be instead of 2 million, it will be instead of 51%, it will be 39%. And also, it will be instead of 2 million, will be 2,336,000 tons per year. It means it means it will be 11%. It's for port, of course, but it is not a problem of tanker ship because they just took petroleum and go. But the most important point, how much I will give the supply for this tanker ship?
Exactly. This is what I'm asking.
Yes.
What is your handling capacity? How much can you handle at the port? Is 2,336,000 the maximum?
Yes,
Or there is still room for improvement?
According to calculations, it's 2,336,000. That's okay.
One more question, please. Yes. What do you know? What is another name of volumetric type of pump?
Another type?
Another name of volumetric. It is hydrostatic and positive displacement pump.
Yeah.
Have you listened my lecture, maybe? No? Yes. You understand it,
Good.
Thank you.
Thank you very much.
That's good.
Thank you very much. I'm so glad to do it. Thank you. Thank you very much.
Thank you very
I think you like it. That's why so many questions. Thank you very much. Thank you.
It's good.
Thank you.
Our next speaker is Alexander Ivanov, preparation and destination of water with the help of renewable energy sources in Russia. It's currently a producer. Assistant Monovan advisor,
Okay. Good day, dear commission members. My name is Alexander Ivanov. Let me introduce my dissertation. Preparation and desalination of water with the help of renewable energy sources in Russia, Crimea Peninsula. The choice of actual theme was influenced by the actual problem. In 2014, the North Crimean water canal, which supplied fresh water to the peninsula, was blocked by the authorities of Ukraine. And this led to a shortage of fresh water, of course. And the priority task of Russian Federation is to ensure the water independence of the peninsula. The situation is complicated by the energy dependence of the peninsula on the external suppliers, which is before 2014. That was Ukrainian power plants. Now it's mainly the Rostov nuclear power plant. So the main goal of my team is to make consideration of the solar power plant as a source of electricity for water desalination plant and make a feasibility study. Energy blockade. In 2015, the energy blockade of the peninsula began. The energy supplies from Ukraine were interrupted. So, all generation of electricity in the peninsula is less than 30% of total consumption and provided mainly by internal mobile gas turbines, which is very small. And this is really a problem. So, to successfully implement all this project, it's necessary to provide a sufficient source of electricity, a sufficient capacity of electricity. So this source became the main object of my research. The solar power plant, 40 megawatts DC nominal capacity. Next. A few words about the potential of renewable energy sources. According to World Energy Council, the global installed capacity of solar power plants has grown from almost zero to more than 200 gigawatts. More than 200 gigawatts in the last decade. More than 15% of the world energy capacity has met with the help of renewable energy sources. Generation prices are declining due to the improvement of technologies. Russian organizations show interest in renewable theme. For example, Havel company is focused on the high-tech production of solar modules and construction and operation of solar power plants also. The main water desalination technologies which are used. There are two much different technologies that are used, but it should be said about two large groups: membrane processes and thermal processes. 68% of all desalinated water obtained by membrane processes. The most frequently used is reverse osmosis technology. Its advantage is high degree of water purification and far from the worst indicator of specific energy consumption. 30% of water desalinated by thermal processes, such as multi-stage flash and multiple effect distillation. We can see by the graph that until about 2000, the thermal processes prevailed on the market, after which the membrane processes went up sharply. In my research, I consider the membrane processes reverse osmosis technology. The water desalination issues. First of all, is specific energy consumption. We know that such technologies, such as reverse osmosis technology, the cost of desalinated water mainly composed of the cost of electricity consumed. This is the main problem. Next is harmful heavy isotopes. You know that seawater contains in large concentrations heavy isotopes of hydrogen, such as deuterium. Deuterium is very harmful for human health and can even lead to cancers. This is very bad. Saline utilization. As a result of desalination process, we have two products. First is desalinated water, of course, and second is concentrated brine, which requires a total disposal. This is three main problems. Let's go into details. In order to consider my project, first of all, I reviewed the solar radiation level map. According to this map, here is Crimea Peninsula. We have about 12 or 1400 kilowatt hours per meter square of solar radiation level D and I. I think this is the sufficient level of solar radiation for operation of desalination plant. I'm sorry, not desalination, but solar plant, of course. Next. Project consideration, baseline data. First of all, I consider the city of Sevastopol, which locates in the peninsula. The water productivity should be equal to 37,000 meter cubic per day, which is 40% from total consumption. This value I got from regional standards. I reviewed the regional standards and got this value. Next, the specific energy consumption of water desalination plant is 4.46 kilowatt hours per meter cubic of desalinated water. And these results gives us the required energy consumption of desalinated plant, which should be 60.2 gigawatt hours per year. Next. In my work, I am using SAM software to implement the calculations related to solar power plant. And the initial data for this software should be as follows. First, geographical data, which is humidity, precipitation, wind speed, solar radiation level, and so on. Use solar modules from Coursera manufacturer. One module has power of 310 watts DC per unit, and voltage is 14 volts DC. Use inverters from TMEIC company. One inverter has capacity of 2700 kilowatts AC. System design. There are 129,000 panels, 12 inverters. DC to AC ratio is 1.23. Also, the spatial orientation of the panels are specified, and so on. Efficiency losses. The software allows you to specify solderings, wirings, system degradation losses, and much different some other parameters. Economical data. Direct cost of solar panels, inverters, installation labor, operation and maintenance, and so on. Let's review the output data of the SEM. First of all, our solar power plant will generate 51.2 gigawatt hours per year. Here is the monthly electricity generation graph. By the way, do you know what does this red line mean? Maybe you know? No, it comes from initial data. This is the required level of the energy which requires our water desalination plant. So we must need to provide this level of energy. Here is the surpluses of electricity, and here is electricity is lower than we need. Next, energy yield is 1300 kilowatt hours per kilowatt of installed capacity. Net capital costs will be $152 million, and payback period will be 26 years. Do you think it's okay? What do you think? I think it's not okay.
It depends on the question you are solving. Okay, we come back to that.
But now I think it's not okay. But the next part of my calculation will be the improvement of this project. So I studied the factors affecting the payback period and make a conclusion. Let's review this. The factors affecting the payback period. I reviewed 3 factors: prices of operation and equipment and so on, specific energy consumption, of course, and efficiency losses of the system. And I investigated these factors and made a conclusion that 20% of system optimization for both of these, for each of these factors will give us the 10 years reduction in payback period. It's possible to demonstrate a graph of one factor, the dependence of payback period on the specific energy consumption. In initial data, we have 4.46. It's somewhere here. We have the payback period 26 years, which is insufficient. And if we reduce this value by 20%, which would be 3.57, which is here somewhere. And we will get a new payback period. It's about 21 years due to this factor. Conclusions. So, I have investigated the solar power plant and have some results. First of all, my power plant will generate 51.2 gigawatt hours per year, and installation plant will generate 12 million meter cubic of fresh water per year. I have calculated the payback period. The first result was unsatisfactory, and I investigated the factors affecting the payback period, and new value will be 16 years of payback period. So I believe that my research goals are reached, by the investigation is not fully completed. So the proposal for next work. First of all, I propose to more detailed calculation of payback period and more complete and accurate initial data and work in the same software. And also, I think it would be better to consider the hybrid renewable power plants in order to exclude the seasonal factors and time of day. And last thing, to make an SWOT analysis to investigate the weaknesses and strengths of my project, and investigate the further direction of project. Thank you for your attention. Now you're free to ask any questions.
Alexander Ivanov showed excellent performance throughout his studies with 9 excellent grades, 4 good grades, and 1 satisfactory. His academic supervisor believes that the incomplete material analyzed and recovered in an unusual way and deserves an excellent grade. Do you have any questions?
Yeah, let's come back to the payback period. Page 26 and 16. Yeah, I remember a few. My question is it always a matter of payback period? Did you get a question? Is it always a matter of payback period? Now, you have 2 payback periods, 26 and 16.
Yes.
If I were going to choose, of course, I'll choose 16 years.
Of course.
Exactly. So what I'm saying is it always a matter of payback period to make a decision in this particular case?
I think it depends on the time which this project is going to be working. No?
Decision making, right?
26
years, 16 years. I'm an investor, I go for 16 years. Okay?
Yes.
Yes, but now I have to make it. Is it always that I have to go with payback period? Who are you making this project for? And will they always fall on payback period or they will fall on other considerations?
I don't know about the considerations, but I think we make this project for government, of course.
Exactly. So the government has social responsibility. So that is the answer to my question. They might decide that even if the payback period is not good, they are doing a social, they are performing a social service. They have to give water, drinking water to the people of Kenya. And so even if the payback period is not good, the consideration that they are providing water outweighs the payback period. You know my point?
Yes.
Practical question. You said about Sevastopol area. You don't speak about Sevastopol area, but as far as I know, near Sevastopol there is a lake that they also sometimes call Sevastopol Sea, and so Sevastopol, the situation with drinking water in Sevastopol region is much more better than, for example, near Kerch or near other regions inside Crimea. Why do you choose?
I got your point. My project is not strictly related to specific location, so it can be located in different places because the Crimea Peninsula has sufficient solar levels for this project, so I think it's not a problem.
I have one question. Do you take into account the cost of mineral which add to the distilled water for drinking?
No.
No. Yes.
This is a good question because I said about this in the problems. So I recommend, as I read the materials, I make a conclusion that it's recommended to use this water not in food, but for communal and technical purposes.
Yes. Thank you very much.
Thank you.
Questions? Thank you for your presentation. And you said about hybrid
power plants.
Tell about it.
Okay, I can tell you. So, for example, here the monthly electricity generation graph, we can see that the maximum solar activity is due to the May, June, July, August. So the summer is maximum solar activity, and due to this month, we can see that the energy is not enough for the water production. So what can we do? We can investigate the other renewable sources, for example, wind source. As we know, the wind source graph will be like mirror. So this wind source will produce maximum due to winter month and slightly lower due to summer. So we will compensate these two sources, and I think this is a good opportunity.
Wind. Maybe nuclear.
Nuclear. I don't know about nuclear.
What kind of wind in January?
What is the wind speed?
Maybe.
I didn't investigate these levels of wind speed, but when I worked in the STEM software, the geographic data file consists include the information about wind speed. So if we could consider this opportunity, we can easily use that information from the STEM software.
Speed not enough, and
If the speed would be not enough, we can consider the diesel generators. Do you know that in Russia we have some hybrid diesel and solar hybrid plants? As I remember well, one is from Yaulu, and in that place there is a hybrid plant about 100 kilowatts. There is solar panels and diesel generator, and this plant show us sufficient results.
Thank you very much. Alexander Ivanov was the last speaker, and now the committee will discuss the results of your presentation. So we kindly ask you to wait outside.
Должен отметить прогресс и в оформлении, Grow and Должен сказать, что Please, close the door.